this video is for the quadratic formula notes. So this is kind of the go-to solution for solving quadratic equations. This is an easy equation that you can use on any quadratic to solve it. And so our formula is here. It's x equals, and then we've got a fraction. So in the numerator, it's negative b plus the square root of b squared minus 4ac, and then that's over or divided by 2a. Okay, so how we use this thing. And then we talked a little bit about this, but the solutions for quadratic formulas are 2 solutions, 1 solution, and no real solutions. So this is a good note page that you can use to identify the types of solutions that these might have. So we've got a quadratic equation, x squared plus 3x minus 2. Always make sure that your quadratics are in standard form, that they're set equal to 0, and that all your variables, all your constants are on one side together. So we need to identify the a, b, and c values. So the a value is the coefficient for this x squared. There's no coefficient, it's just x squared. A equals 1. The b value is what's in front of the coefficient of the second term, or in front of the x. So here it's a 3. And then c is your constant term. So it's minus 2 here, so it would be a negative 2. And all you do is you substitute these values into the quadratic formula. So b was a 3, b was a 3, a was a 1, c is a negative 2, and a is a 1. And so there's different ways you can do this. You can do this in one fell swoop in your calculator, but that doesn't always work because we want this in simplest form, and if it happens to be an irrational number, then you're going to have to go back and simplify it. The other thing is, too, is you notice that our formula here is a plus or a minus. So you can see on this one that I put a plus sign to start off with, and then I'll show you how to go back in and change that to a negative. But anyways, you can type this whole thing in, 2 times 1. And you can see here that we get this crazy decimal. So we need to do this by hand. So we're going to start off with x equals negative 3 plus or minus, and then our square root. And we're just going to start simplifying this down. So 3 squared is 9 minus, and then I'm going to multiply these 3 pieces, the 4 times 1 times negative 2. And I get a negative 8. And then all of that is over 2 times 1 is 2. And then x equals negative 3 plus or minus. All right, 9 minus a negative 8. 9 minus a negative 8 gives me a 17 over 2. So knowing that 17 is prime, I know that that will not simplify down any further. That's as simple as it's going to get. Okay, so there's not really much that I can do here to simplify because 3 is not divisible by 2. Okay, so my solutions here are negative 3 plus, we're going to do plus first, the square root of 17 over 2, and that should be an x equals, and then x equals negative 3 minus the square root of 17 over 2. And so what these solutions are on the graph, these 2 points here, those are our solutions. So if the graph of a quadratic crosses the x-axis in 2 places, it's got 2 solutions. Okay? All right, we're going to look at one solution next. Let me do this a little bit here where I can maybe adjust so we can see everything. All right, so new quadratic, x squared plus 6x plus 9. So we're going to identify our a, b, and c values. So a is 1, b is 6, c is 9. Okay, so b is 6, b is 6, a is 1, c is 9, a is 1. So we're going to do the same thing here. We're going to type this all in one fell swoop and just see if it'll simplify. And then I'm also going to show you how to simplify it by hand. So we've got negative 6, and we're going to do plus first. The square root of 6 squared minus 4 times 1 times 9 over 2 times 1. So when I hit enter here, you see that I get a -3. So I know one of my solutions, x equals -3. And we know this already has one solution because it says it. But they don't always tell you that this quadratic has one solution. So you do need to go back. And so I don't know if y'all saw what I did. I'll do it one more time. But you need to change this to a subtraction sign. So again, how I did that, I pressed the up arrow key till I highlighted the quadratic formula, and then you can just scroll with the keys, to change that plus to a minus. So you don't have to type the whole thing in again. But we can see we get -3 again here. If you do it by hand, x equals -6 plus or minus the square root. 6 squared is 36. 4 times 1 times 9 is 36. All of that's divisible by 2. X equals -6 plus or minus 36 minus 36 is 0. So square root is 0. And what you're looking for under that square root are your perfect squares. That page that I gave you that has all your perfect squares listed. And then all that's over 2. So square root of 0 cancels itself out. So what we have is x equals -6. I don't need the plus or minus anymore. Plus or minus 0 doesn't make a difference. So it's over 2. So you can see that you get one solution here when you have a 0 under your radical. And one solution on the graph looks like this. The parabola is going to come down and just barely glance that x-axis, and it's glancing it at x equals -3. Okay? All right, we've got one more here, and these are no real solutions. So again, I just want you to see what it looks like. So a is 7, b is 9, c is 5. Okay, we fill everything in. b is 9, b is 9, a is 7, c is 5, a is 7. So I'm going to go ahead and just work this one by hand. If you stick it into your calculator, I'll show you what it looks like in your calculator too. So, all right, so we have -9 plus or minus the square root of 9 squared is 81. Then we've got 4 times 7 times 5. So 4 times 7 times 5 gives me 140. So we're going to minus 140. 2 times 7 is 14. All right, x equals -9 plus or minus 81 minus 140. Here's where you can tell that it's no solution. We cannot square root a -55, a negative number, -59. What that leads to is called no real solutions. There's a solution, but it's not a real number. And so this is over 14. So immediately when I get here and I have this negative under the radical, I know automatically that it's no solution. And no solution looks like the graph here. You can see that this parabola comes down, but it never reaches that x-axis. So that's what it looks like if you have no real solution. What your calculator will spit out, I'm just going to put a negative radical in there, is this code, non-real answers. And so that's what you'll see if you try to type this starting quadratic formula into your calculator.